Here we're going to look at quadratic inequalities. It looks very similar to linear inequalities in the fact on how we're going to solve them. So here's a quadratic function, has the equal sign with the f of x. A quadratic equation value, the f of x is actually now is 0, right? That's an equation, and then now a quadratic inequality, the equation symbol is changed to a greater than or less than or greater than or equal to. So here's an example. What we're going to do is look at f of x equals x squared minus 4. Now let's quickly graph that. If we graph, let's just move down 4 units. I quickly graphed it here. Now there's the bold line and the dotted line. Now if we look at where is y equals 0, right here. Now these values are greater than 0 for the y values, right? Greater than 0. These values are less than 0 for the y values, okay? So we want to make this inequality either greater than or less than 0. We can see which values are doing that. Here are the greater than, here are the less than. Right at the point right there, here and here, these are where it's equal to 0. Okay? So if this were an example, x squared minus 4 less than 0, if we wanted to solve this, when is this parabola less than 0? When is this y values, right? Y values output less than 0? Well, they're less than 0 here. But that would be between the numbers -2 and +2 on the x-axis. So we'd say our parabola or our equation is less than 0 between -2 and 2, and that would be the answer. If we want it to be greater than 0, so look, I just switched the sign from less than to greater than, then we look at the bold lines, because the bold lines are the y values that are greater than 0. All these y values that make this portion right here are greater than 0. So now we'd split it up. We'd say all the x values from -infinity to -2, which is right here, unioned with 2 to +infinity, right here, make these y values. So that would be the answer to this graph, the greater than. Basically the outsides are the greater than and the inside is the less than in this case. Now if we wanted to include the y equals 0 point, that point and this point, basically we'd put a greater than or equal to or a less than or equal to. In this case I have a greater than or equal to, so notice that the -2 and the +2 change to brackets, because now we'd be including these 2 points where it actually equals 0. So how do we solve a quadratic inequality? You have to put it in standard form. You then have to solve it equal to 0 because you want to find those zeros of the quadratic. Where is it? Right here and here. So you have to find it equal to 0. Then draw a horizontal line and draw the zeros in there with an open circle for a strict inequality and a filled in dot for an equal to. Check the leading coefficient for whether it opens down or opens up, because which way is the parabola opening? Up is positive, negative leading coefficient is down, and then write the solution interval notation. So here's an example. We're supposed to solve x squared plus 2x is less than 1. Well, we need to solve it equal to 0, so we need to subtract 1 on both sides. So if I go subtract 1, and then subtract 1 on both sides, then I get this equation here. And now I can solve that with factoring or whatever, but here it doesn't factor, so I got to use the quadratic formula. So I stick the a, b, and c into the quadratic formula. I get my two zeros of being -1 plus or minus the square root of 2. Alright, so look, I didn't graph it. It wasn't like a really super graph. I just drew in a parabola. I graphed both zeros. 1, 2, just by drawing a horizontal line through there. And so I have -1 minus the square root of 2 is 0, and -1 plus the square root of 2 is 0. Now I just need to answer the question. When is the graph less than or equal to 0? That means the y value, right? This is output. When is the output less than or equal to 0? Here. Less than or equal to 0. So the answer is between them, right? This is less than or equal to 0 when x is between -1 minus square root of 2 and -1 plus the square root of 2, including.